The abstract factory pattern is another creational design pattern that's very similar to the factory design pattern. So if you're unfamiliar with the factory design pattern, I suggest checking that out in my other video, which I'll link below. The main difference between the abstract factory pattern and the factory pattern is that with an abstract factory, we're going to be creating a family of related objects. And similar to the factory pattern, our abstract factory is going to be a class, so again, we can leverage the benefits of polymorphism with our abstract factory, which we are going to see in our demo. And I hope this demo is useful because I feel like one of the biggest issues with this pattern is finding a use case where you actually need a family of objects to be created. That isn't just dogs or cats or shapes or triangles or all those examples that are out there. So hopefully this will make the pattern a little bit easier to understand so you can apply it in your own applications. That said, let's hop into the demo. So I have this product service here, and this class is responsible for getting a product by ID and saving a new product. So inside of these methods, we open up either a file product reader in order to get a product by ID, or a file product writer in order to save a new product. And we put these in using statements so that we can dispose of the class when it's done, because since we're dealing with files and external resources, there's typically resources that we need to dispose of when we're done, such as a file handle in this case. So as you can see, we're actually instantiating our file product reader and our file product writer. And this is an issue because what if I wanted to change this to, say, a database product reader or a database product writer? I would actually have to change it right here and actually instantiate a different class. And as we know, that would be a violation of the O in solid, the open-closed principle. But no worries, the abstract factory is here to save the day. So our product reader and our product writer make up the family of objects that we need within this product service. So let's create an abstract factory that's going to give us back a new file product reader and a new file product writer. So I'm going to come over here to my services and I'm going to add a new item, and I'm going to call this the file product communicator abstract factory. So kind of a long name, but I do like to suffix this with abstract factory, so anyone who looks at this class is going to be like, oh, this is an abstract factory. And I chose file product communicator as the name of my family because I feel like communicator is a good word to describe something that reads and writes. So let's make this public, and let's add some methods to create our family. So first, let's add a method to create our product reader. So it's going to be public, and it's going to give us back our file product reader. And we're going to call this create product reader. And in our case, we are going to pass in no parameters to this. And all we're going to do is return a new file product reader. And our file product reader actually needs a file name, but I'm going to get the file name from a field within this abstract factory. So let's add a field for that. And that file name is going to come from the constructor. So let's add a constructor for that. And keep in mind, you could actually get the file name from this method, and then the product service would provide the file name. But in this case, I actually don't want the product service to have to know about the file name. All I want this product service to do is just create the writer and not have to care about the file name. That's going to be the responsibility of the abstract factory. So really, it just depends on your use case. In this case, it's going to be as a class field. Next up, let's add our method to create our file product writer, and we'll call this create product writer. And same thing, just going to return a new file product writer. Awesome, so that is actually all we need to do for our abstract factory. Very simple implementation in this case. I assume there could be scenarios where it's a bit more complex, but this gets the job done for us. So let's begin using our abstract factory. So let's get the abstract factory in a field. We'll just call this the product communicator abstract factory, and that is going to come from our constructor. So now that we got our abstract factory, we can use it in our getById method because we want to get a product reader, and then in our save method we can use it to get our product writer. And now let me update my program.cs where I set all this up. So I initialize my product service here, but now it needs the abstract factory. So let's create one of those. And I need to pass in my file name, which is still in the product service. Let's move that up to my program.cs. and just pass it in, and then pass in my abstract factory to my product service. Cool, so let's run this with our new abstract factory. All we're going to do is get a product, write it to the console, and then save a new product to this products.json, which we currently have one product. So let me run that. So here we go, we print out our cantaloupe, and then this is the product that we saved, a desk. Come back into my products.json, and there is the desk. So it seems like our abstract factory is getting the job done, creating our reader and creating our writer. Great, now our product service doesn't need to know how to instantiate a product reader and a product writer, and now it doesn't need to know about the file name that's required for the reader and writer, but now I need to take this a step further so that I can swap out this file abstract factory for, say, a database abstract factory or an in-memory abstract factory without having to change any of this. And that's going to require a few steps. So first off, the objects that our abstract factory create need to be interfaced. So let's come over to our file product reader, and I'm going to right click this and extract it to an interface, and it's just going to be an iProduct reader, and it'll just have these two methods on it. And let's take a look at that interface. Perfect, that's what I want. And same thing for the file product writer, extract to an interface, just an iProduct writer, and there we go. So now we can update this using statement to just depend on those interfaces instead of these concrete file product reader and concrete file product writer. So instead, we can make this the interface, so an iProduct reader and an iProduct writer. And whoops, we have a little issue here. These interfaces need to implement iDisposable so that we can use them in the using statement. And we can get rid of this on the interface because iDisposable already requires that method, and then same thing for the iProduct reader. And the last step we need to do is depend on an interface of our product communicator abstract factory. So let's go into the abstract factory that we created, and now we are going to give back the interfaces instead of these hard concrete implementations. And now let's extract our abstract factory to an interface, and we'll just call this the iProduct communicator abstract factory. Here's our interface, looks good. And now back in our product service, let's depend on that interface. And now if we look at our product service, it does not need to know anything about a file. So that said, we can pass in a different implementation of our product communicator abstract factory, read and write to a different data store, and not have to change anything in our product service. So let's do an example of that. Let's add a new abstract factory, and I'll call this the in-memory product communicator abstract factory. We'll make that public and implement this interface for our abstract factory. So there's our factory methods for creating a product reader and writer. And now we need to actually create classes for our in-memory product reader and in-memory product writer. So it will require some work to extend this, but that's just because, that's just what our product service requires. It needs a product reader and it needs a product writer. So we're going to have to create those. An in-memory product reader, make that public, implement our product reader interface. In this case, we'll have nothing to dispose. And I'm just going to return a new product. So here we go, a dog for $5, what a bargain. And then let's add our in-memory product writer, implement our product writer interface. Don't have to do anything on disposing. And in this case, we're not even going to save the product, we're just going to return it. So kind of a violation of the L in Solid, the Liskov substitution principle, because we're not actually saving this. But for demo purposes, it gets the job done. So back in our in-memory abstract factory, let's return our new in-memory product reader, and then for our product writer, the in-memory product writer. And now in my program.cs, if I want my product service to use the in-memory implementation, all I have to do is change this variable right here. So let's change this to the interface, and then all I have to do is change this instantiation right here to the in-memory abstract factory. Takes no parameters, and let's run this. There's my dog for $5, and there's the desk. And our desk actually has an empty GUID, so I assume our in-memory product writer could just give it a GUID. There, now we'll consider this not a violation of the Liskov substitution principle. Great, so we were able to change our reader and writer data source just by passing in a different abstract factory. Didn't have to change anything in these methods. But not only did this make this flexible for changing data sources, but it also made it extremely testable. Because before, we had no choice but to actually read and write from a file if we were going to write unit tests for this class. But now if we want to write unit tests, we can just pass in some kind of mock for this abstract factory and then test this without having to read and write to or from a file. So even if you don't have plans to implement some kind of in-memory product writer or database product writer, it's still useful to set up an abstract factory in this case and interface it, and then depend on interfaces for the objects that the abstract factory creates. So the abstract factory pattern use methods to create a family of objects, and it makes your code more flexible and more testable. So hopefully you guys can apply this to your own applications. If you have any questions, criticisms, or concerns, be sure to leave them below in the comment section. But other than that, leave a like and subscribe for more design patterns on the way. Thank you.